Number 1 is to solve each equation and check for extraneous solutions. So a reminder that extraneous solutions are solutions that, when plugged in, do not end up working. Mainly because when the denominator becomes 0, you would have an undefined value. So for each problem, solve and then make sure you check your answers. In this case, this can be solved by cross multiplying since we only have one fraction on each side. So 5x plus 20 equals 5x squared plus 10x minus 40. So we're going to end up with a quadratic, so we need to set it equal to 0. So 0 equals 5x squared minus the 5x becomes plus 5x, minus the 20 would become negative 60. This has a greatest common factor of 5, so we can divide everything by 5, and that becomes x squared plus x minus 12. If we factor that, we get x plus 4, x minus 3, with solutions of negative 4 and positive 3. So checking our solutions, we need to check whether negative 4 makes either of the denominators equal to 0. And it does. Right here, negative 4 plus 4 is 0. If we're dividing by 0, that means it's undefined. X equals 3 when we plug it in does not make either denominator 0, so that's a valid solution. Part B. Here we solved by cross multiplying. Another way to solve a rational equation is by getting common denominators. So in this first fraction, we're missing the x plus 6. Multiply the top and the bottom by the same thing. Here we're missing an x and an x plus 6. And here we're just missing a 3x. Once all denominators are common, then we can ignore the denominators and rewrite just the numerators. So 2x plus 12 plus 2x squared plus 12x equals 24x. So again, we have a quadratic that we need to set equal to 0. So 2x squared, 14x minus 24x is minus 10x, and then plus 12 equals 0. We can divide all of that by 2, which gives us x squared minus 5x plus 6 equals 0. And then factoring that, x minus 3 times x minus 2, which gives us solutions of positive 3 and positive 2. So again, make sure you check for extraneous solutions. Plugging these into the original problem, none of the denominators become 0 for either of these, so both of them are valid solutions. X equals 3 or x equals 2. Part C is another example of one where we can do common denominators. We can't cross multiply the way it's written because we have 2 terms here and 1 term here. So in this denominator, we're missing a 2. In this denominator, we're missing the entire expression, 2 times x plus 8. So this is a 2 quantity x plus 4. You can write it like this, or you could write it as 2x plus 8. So now all denominators are common, so we can just focus on the numerators. 2 gets multiplied by this 4x plus 28 equals, or minus, 2 gets multiplied by 2x plus 8 quantity, so negative 4x, negative 16, and then equals 2x plus 20. 4x and negative 4x cancel, so 28 minus 16 is 12. Subtract the 20 and we get negative 8 equals 2x. So x equals negative 4. And if we check for extraneous solutions, negative 4 makes the denominator here 0. So that would give you an undefined value. So this is extraneous, which means we would end up with no solution. All right, and part D. Here's another one where we could cross multiply or get common denominators. If we cross multiply, this would be 4x squared minus x cubed equals 2x squared minus 8x. If we set this equal to 0, I'm going to make the x cubed the first term, subtract the 2x squared, that would be plus 2x squared, add the 8x. Then we can factor out a negative x and be left with x squared minus 2x minus 8. So negative x times x minus 4 times x plus 2 equals 0. Now we have three solutions here, 0, 4, and negative 2. We need to check all of these to check if any of them are extraneous. 0 doesn't make either denominator equal to 0, so that is a solution. 4 does make the denominators equal to 0, so that's extraneous. And negative 2 does not make the denominator 0, so negative 2 is also a solution.